Evaluating and simplifying algebraic expressions. So we're going to have to get some definitions down first. We have first the constant. That's a number that does not vary, such as a 5, 7, -2, or pi. These are numbers we work with often. These are just our numbers. Variable is a placeholder for a value that can vary given different applications. These are represented by letters such as x or y. Algebraic expressions would be a collection of constants and variables joined together by the algebraic operations of addition, subtraction, multiplication, and division. An example of an algebraic expression is 2x plus 3y squared. So list the constants and variables for each of the algebraic expressions. So for this first one, the constant would be 3, or you could say -3, but that's the operation, subtraction between them. But the constant is 3. Then 2x, so x is our variable, and then 2 is the coefficient of the variable. It's not a constant. I mean, 2 is a constant in itself, but in this application, it is the coefficient of the variable. For the next one, the constant, I should say I'll call them coefficients. They're going to be 1/3 and pi. And then the variable would be r. The 3 there is a power. For this next one, you could express this, by the way, and I'm getting a little ahead of myself, as 3m to the 4th n cubed. This comes up later on. To the 1/2 power if you need to see it that way. So R3 is a coefficient, and then the variables are going to be m and n. By the way, these examples are similar to the ones that are in the book, if you do read the lessons in the ebook. So that's where I'm pulling these from. Evaluate the expression 3x minus 5 for each of the following. For x being 2, we're going to put the 2 in place of the x. So 3 times 2 minus 5. That's 6 minus 5, which is 1. And then 3 times -4 minus 5. It's -12 minus 5, so it's -17. Then we have 3 times 5/3 minus 5. Well, the 3's will divide out. Leaves us with 5 minus 5, which is 0. And then 3 times 0 minus 5 is 0 minus 5, which is -5. Let's try the next one. Evaluate each expression for the given variables. X minus 7, we're going to evaluate this for x equals 7. So 7 minus 7 equals 0. Put a 5 in here for the t. So we have 5 over 2 times 5 minus 1. That's 5 over 10 minus 1, or 5 over 9. Next one, we're going to put the 3 in there for r. So it's 4/3 times pi times 3 squared. That's 4/3 times pi times 9. The 9 and the 3 will reduce. So 4 times 3 is 12, and the pi is still there. Here we have a plus ab plus b. A is 5, b is -3. So that's going to be 5 plus 5 times -3 plus -3. So that's 5 plus -15 plus -3. So that's -10 plus -3. It's going to be -13. And then we have the square root of 2m squared n cubed, for m being 3, n being 2. So that's going to be the square root of 2 times 3 squared times 2 cubed. So it's the square root of 2 times 9 times 8, and that's the square root of 144, which is 12, By the way, if you want to see this a different way, because this is a 2 and that's a 2, I'm getting a little ahead of myself here probably, but that could have been written as 3 squared times 2 to the 4th, and the power out front is 2, so therefore that's not power. The index, the radical, is 2 for a square root, so we could have divided each of these by 2, so it would be 3 to the 1 times 2 to the 2, so 2 divided by 2 is 1, 4 divided by 2 is 2, so it's 3 times 4, which is 12. But I think we get to that in a later lesson. I think that's it for this part, and yeah, we'll do formulas in the next video.